Good afternoon, everyone. My name is Li Xu from the CPC. My presentation is title is Soil Moisture Analysis and Assimilation from the National Water Model version 2.0 application for the U.S. drought monitoring. This project is a OAR service level agreement project. The name is Application of National Water Model for the Drought Monitoring. It's during 2017 to 2020. This is a multi-center project including OWP, CPC, and the PSL. The CPC part is led by the PI is David DeWitt, and technical lead is Kingsley Mo and Hailan Wang. Also, the major staff including Mutu, Chilia, and me. The monthly technical connection is organized by the Mimi Hu at the PSL. The goal of this project is to evaluate the soil moisture anomalies calculated from the National Water Model retrospective simulation in the analysis and assimilation cycle to develop a prototype drought monitoring product based on this anomaly. The product will be shared with the drought monitoring authors and the drought outlook forecasters. Brief outlines. First, we will briefly introduce the National Water Model 2.0, and the second, we will introduce the soil moisture analysis and simulation cycle at the National Water Model, and also soil moisture percentile calculation based on the retrospective simulation from National Water Model, and then we evaluate the performance diagram against the USDM or US drought monitoring from the recent 20 years, and the last one is the conclusion. National Water Model 2.0 is consistent. It's an operational hydraulic modeling framework based on the WRF hydro, simulate and forecast how water moves through U.S. rivers and streams, produce hydrology guidance at very fine spatial and temporal resolution, and complement the National Water Regional Forecast Center hydraulic guidance. Its output is hourly to 200-meter resolution soil stream flow and 1 kilometer soil moisture output, and over 2.7 million river reach in over the corners. The forecast variable including stream flow, surface runoff, soil moisture, evaporation, snow, and other parameters. The National Water Model 2.0 retrospective simulation during 1993 to 2018 are available to compare with analysis to obtain real-time drought anomalies. The NWM 2.0 forecasts are real-time only. There are no handcasts available right now. The land component of National Water Model is non-MP. It's the resolution is 1 kilometer for layer soil moisture. The model physics including 4 land surface physics, including water balance at bare soil, vegetation, and canopy, and 4 energy balance, including 1 complete snow model and a lake model and per moment forest modeling. The retrospective simulation is forced by the NRDAS-2 meteorology forcing, downscaled and regraded to the 1 kilometer NWM grid. The time range is including 26 years handcast. It's currently available on Amazon Web Service. We are now a big data project. We analyze the volume soil moisture at 1 kilometer national water grid, and to reduce the data storage, we temporal spatial and temporal average the soil moisture to daily mean and to the 1/8 degree with the same as NRDAS resolution over corners. The soil moisture percentile, we use a very similar method to as NRDAS to calculate the soil moisture. You use 5-day nearby soil moisture data to concatenate a long time series for the experiment PDF. With analysis of the total column of the top 2 meter soil moisture and also top soil is up 40 centimeter soil moisture. This slide shows the soil moisture evaluation against the in situ observation soil moisture observation from the SCAN network and the USCI network. We can see this figure from the PSL direction. We can see for the soil moisture less than 20 percentile at the top level 10 to 40 centimeter, the critical success index is between 20% to 40% at most locations across the US, with a lower value in the desert southwest and a higher value at the east and scattered location. To further evaluate against the US drought monitoring, we first rasterize USDM to the regular latitude grid, and then we further separate the US drought monitor to the long-term drought and short-term drought. By the definition, the long-term drought is defined by the drought persisting longer than 6 months in the past 26 weeks, and the short-term drought is the remainder just less than 6 months. This figure shows the drought area covered over corners monitoring by the USDM in the top panel and by the National Water Model in the bottom panel. The top panel shows the D0, D1, D2, D3, D4 drought over the recent 20 years. And the bottom panel shows the recent 18 years. So, 18 years, National Water Model soil moisture below 30 percentile, 20 percentile, 10 percentile, and 5 percentile, and 2 percentile corresponding to the D0 to D4 drought. We can see from National Water Model slightly underestimated D3, D4 area compared to USDM. And in the overall, it's slightly underestimated the drought area. But we can see very clearly the 2012 the Great Plains drought. It's over 80% of the area in the drought, but we can see most being catch the National Water Model. And also 2002 the western drought very clearly catch by the National Water Model. 2007 the southeast drought, and the 2011 Texas drought, and the 2013 to the 2017 the California drought. All can be captured by the National Water Model. This slide shows a performance diagram of National Water Model soil moisture percentile against USDM by the D0 and above drought. This is summarized multiple score. First is the this is the vertical axis is by the probability of detection. It's measure how much the National Water Model can correct detect the drought, and horizontal axis is the success ratio, which equal to 1 minus the first alarm ratio. It shows how much correct ratio of the National Water Model indicates drought, corresponding the USDM also indicates drought, and the count color is the critical success index. Show as this color map, and the dashed line is the indicated bias, which means the total ratio, how much drought can indicate by the USDM National Water Model compared with USDM, and each color dot is for the each week during 19 years evaluation period. For the during 2000 to 2019. So we can show the national water model do a relative moderate successful over the corners, and in the most weak is below 1, bias is below 1, which indicates the national water model will under-detect the drought over the corners. And the highest success ratio is occupied in this yellow color. This is going to match the 2012 Great Plains drought. And this indicates the national water model could be used as do the object drought monitoring. Further evaluate against by the hard to regional by region, we can see this from the total 18 region over the corners. We can see in most high score located in the upper Mississippi, lower Mississippi, and Missouri Red Ring region in the central of United States. And in the east United States, it's relatively good, but the post evaluation is located in the west region, in particular the Pacific Northwest, California, and Lower Colorado and Great Basins have lowest the probability of detection. Also, we evaluate the national water model against the LDAS model in symbol as a benchmark for the soil moisture anomaly by the different drought category. This panel shows the drought predictable of detected POD over the corners by the different drought category. We can say for the D0 drought, it's two model very closely. But in the D3, D4 drought category, the national water model shows slightly improve over LDAS. Very similar in the critical success index. In the D0, D1, almost same, but D3, D4, LDAS national water model show better result than the LDAS. And similar the high key skill score and also the bias over corners. We can show this all the LDAS and the national water models detect the drought over happening corners, but national water model will better detect the drought than the LDAS 2. Also, we found the national water model have some advantage to detect the flash drought, the quick intensity and onset of drought. This is example. 2019 Southeast flash drought happened in the east part of the United States. We avoid over the soil moisture percentile over this region. The top panel is based on the USDM drought monitoring, and the bottom panel is called responding soil moisture percentile detected by the national water model. We can see national water model can well capture this quick intensified drought events over the southeast region, slightly overestimate the drought category, but this is a very good example for the flash drought monitoring by the national water model. During this project, we found two outstanding issues for the current drought monitoring based on national water model. First is the relatively short retrospective period. It's only 26 years. It's relatively short for the drought monitoring. Due to the short period, we need to do some special treatment to estimate the CDF than to estimate of soil moisture percentile. And the second is the mismatch between the precipitation forcing between the retrospective and the real-time simulation. For the retrospective, the meteorology forcing is from the LDAS 2 is consistent, but for the real-time national water model forcing, precipitation comes from the HRR, and MRS blending the meteorology forcing. Let's make some difference we need to consider in the future application for the drought monitoring. This slide shows we do some comparison between forcing. Left shows the NRDAS forcing for the meteorological, and the right is for the real-time national water model forcing. Although the climatology say pretty much each other, but we still can see some difference at the precipitation distribution. And if we compare to the difference and minus by the NRDAS forcing, we can see over west region still have pretty large difference. Across much of US, the national water model analysis and assimilation is relatively wider than the retrospective forcing, and over west region still have shown pretty large difference. This is where the precipitation is last constrained by the radar. So this mismatch in the operation and the retrospective forcing is a major concern, and the potential way to elevate this impact is still being explored by CPC. So in conclusion, the key results, during this project, CPC evaluated national water version 2.0 using in situ observation from the retrospective period 26 years. And for soil moisture, show positive bias over the most corners location, and for the drought events below 10 percentile, it's relative compared to the NRDAS land surface model, slightly better than NRDAS soil model. And the national water model will underestimate drought occur in the West US and East US compared to the USDM. And current National Water Center has implemented a set of demonstration map that can be used for the as a result of this project. And this map has been delivered to the NOAA field office and select partner. The mainly concern is the mismatch between the operation and the retrospective forcing. That's still a major concern, and in the future we need to elevate this impact in the future. Thank you. That's all.